Our second speaker will present ReactGenie, a development framework for complex multimodal interactions using large language models. And we have Jackie Yang presenting today.
Yeah, hi everyone. This is Jackie Yang from Stanford University. Today, on behalf of my co-authors, Yingtian, Yuhan, Karina, Daniel, Anisha, Shuning, Tianshi, James, and Monica. Quite a big team. I'm here to present ReactGenie, a development framework for rich multimodal interactions using large language models. So today we have great graphical user interface apps. We usually call them GUI, and they are powerful and accurate. PowerPoint is one example of them. You can manipulate text boxes, pictures, shapes, and you can adjust fonts, colors, and line styles to a very precise degree on these graphical user interfaces. However, for some tasks, it becomes slow and tedious. For example, for batch actions, if I would like all of my animation to happen in 0.3 seconds rather than the default 1 second, I would have to do it manually for all of the objects on all of my slides. Similar to for last common features, if I want to adjust the underline style, I would have to go through menu after menu after menu to get to this point where I can make that adjustment. So how do we solve this problem? Let's see a demo of my ReactGenie system.
Make all words ReactGenie red and blue.
Yeah, as you can see now, all the word ReactGenie in the slides has been made red and bold simply by saying that. So instead of low-level actions, basically, so this is kind of high-level actions. And then we're trying to do that instead of low-level actions, where users have to select some text, change the color, make it bold, and keep repeating that 3 times because there's 3 ReactGenie on the slides. Imagine a word with 1,000 of them, you would have to do that. So this type of interaction with gesture and voice input is called multimodal interactions. And specifically, we're targeting for a kind of multimodal interaction where you tell the software the high-level goals rather than express those low-level actions. Today, we have GUI frameworks these days, and then you can basically touch different places on the screen, and then it will show you graphics. Usually, for most common stuff, the user have a common goal in their mind. They would have to do repetitive interactions with the app to achieve what they want. And then finally, that will be transferred to many individual actions inside the app's logic code. So what we're trying to do here is leveraging the existing GUI framework architecture and add AI on top of it to help developer build multimodal interactions very easily. So the way we do that is we created this framework called ReactGenie. It's a modded version of React, as indicated by the name. In ReactGenie, the framework provides the multimodal interfaces for the users, so there's a consistent look and feel between different ReactGenie apps. The framework will call the AI models to lower the burden of the developers because the developer do not have to call those LLM models, but have the capability of intelligence provided by the LLM. Finally, we provide a single programming interface for developers to provide features for both voice and touch. The core of ReactGenie starts with the user's command. So the user says something like, make the border of this shape with little dots. And ReactGenie automatically scans the developer's code to extract the code skeleton. Then in the ReactGenie library, we generate a dynamic LLM prompt based on that. And we ask the language model to generate NLPL, is a natural language programming language that we developed that kind of look like this. And one special thing about NLPL, rather than the typical function calling interface, is that it can allow diverse features by training existing functions in the developer's code. Imagine a developer build 100 functions, and that wouldn't be enough feature for the users. But imagine 100 functions can be chained together to create millions of different stuff that the user might want to say to the app. So this is what we created, an LLM-based neural semantic parser for this task. For the developer side, it's super simple. It's very similar to a typical React app. In a typical React app, developer first build features in the state code, which is a bunch of functions and variables. Then the developer built component code to map the data in the state code to a version of the UI. And the UI automatically calls function in the state code if the user clicks on one of the buttons. So this is pretty typical for UI development. What ReactGenie did is super minimal for the developer. The developer simply need to add some annotation in classes and functions and properties so that this can be accessed through multimodal commands. And in the component code side, developer established explicit mapping between the component code and the state code. This allows us to establish a bidirectional mapping between the content on the screen and object in the memory for automatic generation of multimodal interfaces. So we use developer state code for feature, and we use this developer's UI code for rendering the UI while maintaining the mapping between rendered pixel and objects in memory. So for example, in a food ordering app,
reorder my last meal from this restaurant.
If the user says something like this, ReactGenie first uses its neural semantic parser to translate the user's voice command to our domain-specific NLPL. And here we don't know yet what is the user's tap point, so we first uses the developer's UI component code to map the tap point into an object in memory. In this case, it's a restaurant called Taco Bell. And we execute the NLPL to find what is the order, create a new order with the same item, and then place that order. Finally, we use the UI component code again to map that data back to a UI. And as you can see here, there's text feedback, and it will show you what has been done. And now the user can easily place that order again. So for evaluation, we first did a developer evaluation. We want to test to make sure the framework is expressive, so we made 3 apps of different categories. And we found out only 5% of the code needs to be coded for the multimodal interactions. And it's very powerful multimodal interactions. We also tested the development time for expert developers. We asked the expert developer to develop with ReactGenie compared to GPT-3 function calling. We find out developer can build in 1/4 of the time, 1/3 of the code, and it has way more features because function calling can only call one function at a time. On the learnability and usability, we asked 12 novice developers who have never developed any multimodal app before, and all of them can learn and build multimodal apps in 2.5 hours, and the mean time for build is only 67 minutes. And 99% of them can understand core concepts. They answer 99% of the core concepts questions correctly. And many developers asked us if they can use ReactGenie in real-world apps. And by the way, it's open source on GitHub and available on NPM Store. For user evaluation, we tested the parser performance. Out of 111 supported crowdsourced commands, ReactGenie can parse them correctly for 91% of the time. And we find, compared to GUI apps, it saves 40% of time, lower cognitive load, and higher usability. For the high audience, ReactGenie is a powerful system we spent the past two years building with a big team. These days, I've seen a lot of research want to handle users' natural and expressive input, and we have AI that can understand those ambiguous input, and we want them to control the app's logic code. But what is the interface between them? That is the problem. These days, we have traditional function calling or JSON mode that only works with content without logic. And I strongly advocate you try out NLPL, and then everything's open source, so you can try it out. That can represent content and logic with high accuracy. The second thing I want to emphasize is to build multimodal interfaces, we find that it would be super helpful to have a single, easy-to-use programming interface. Today, if you use Siri, for example, if you want to expose an action for Siri, you need to write 100+ lines of code to expose a single function, to tell about what this function is about, what are the parameters and everything. Whereas in ReactGenie, you just add a single line of annotation. We scan your code to extract what is a function, what is a parameter, how can we call it. So developers have limited time, and then having this easy support guarantees a future where all apps are multimodal, and this is our future. The future I'm envisioning. So finally, we have established the right abstraction between UI and logic for generating UI, which are class properties, functions between the developer's logic code and UI code. This allows us to change the screen content by changing data and allow us to map the user's UI manipulation by just changing the data in the memory. So I think this will be super helpful for all generative UI research, so I encourage you to try it out. So ReactGenie is built with my 6 interns, collaborators, and my advisors. It's not only a multimodal framework, it is also a great framework for adaptive UI researchers as a bidirectional abstraction between UI and data. NLPL is also a very, very powerful bridge between users' ambiguous input and structured computer systems for LLM agents. ReactGenie is a framework that is open source on GitHub and you can download it on NPM store. Hope that you can try it out and build React with ReactGenie. Feel free to contact me if you have any questions. And by the way, that link, JYAG, is just my name, Jackie Yang. It's an easy way to remember it. But yeah, happy to take any questions.
All right. Thank you, Jack, for a great talk. And any questions from the room? Yeah.
Hello, thank you for the talk. This is really interesting work. So I'm curious if you could talk a bit about when something goes wrong in this multimodal interaction. Say the user says, you know, order my last meal, but their credit card has expired, or something else breaks in that chain. How does the system navigate that?
Yeah, so we haven't put a lot of thoughts into like what if the translation is wrong. So what you mentioned, I think we don't currently handle it, but it's not too hard because the core idea is that we want to translate the ambiguous input into a concrete output. Once we have that, we have existing ways of handling errors, right? Like if you say, I want to order a meal and the credit card expired, we can easily stop that screen where we can input the credit card number again. That's just like logic stuff that software engineering stuff we have been building for a really long time. One thing we've been paying particular attention to is the errors in translation, because if you say make the ReactGenie red and bold, but it makes another word red and bold, or it doesn't make it bold, it only makes it red or something like that. We try to say that if anything is not reversible, we recommend the developer to put an extra confirmation step that is not exposed in void, so that you basically would stop at a screen where, for example, you place a food order, right? Like if you see if you remember the demo, when you say place my order, reorder what I've ordered from this restaurant, it would create a checkout screen, but then ask user to click the checkout button as a second form of confirmation. Yeah. Hopefully that answers your question.
Any other questions from the room? Well, I have a very quick one for you. You know, thinking about people spending more and more time in the realms of spatial computing, I wonder how much the same principles apply to 3D environments.
Yeah, exactly. I think this project, it doesn't seem like it, but the project originally originated from, like, I was doing a lot of XR research back then, and then one thing I feel like I try to do XR research anywhere, you have 2 controllers, and you have this infinite amount of interaction space in front of you. I just feel like the 2 controllers is not quite for it, right? When I have the full 3D environment, I want to talk with it. I want to be able to point, I want to be able to talk, I want to be able to talk about the things I'm pointing towards. So that's where the inspiration of ReactGenie comes from. I think everything is fully applicable to 3D space. In fact, we're doing a little bit of effort, we haven't quite finished yet, which is one thing we kind of like want to have is that we want to have the bidirectional relationship between data and UI. This is not quite there with something like Unity, but we observed that with Vision Pro, you can program with Swift UI, which is kind of a way of establishing bidirectional relationship between data and UI. So we've been trying to build a little bit towards like, we have an experimental project called SwiftGenie XR, it's going to imagine by the name, it's trying to port this to the XR environments. But we haven't quite finished yet, so if anybody want to port some of those, I'm happy to collaborate.
Okay, well, let's give a round of applause for Jack again.